Welcome to another problem session. So here we have a problem from atomic physics. It comes from JEE. Let's see, get a pen. If you read this question carefully, go ahead and read this question. You will find that this is a interesting problem if you just look at the description. So you have a hydrogen atom here. It's in ground state. And is at rest. Then in comes a photon with energy E1, H and E1, and this electron goes away, and over here is this is a proton and this is electron, and then you have a positron. It just, this electron then lands and makes another atom, and so they kind of, this is a CM, so they rotate about the CM. So, and CM is moving with kinetic energy. And in addition, in this process, when the electron came in and made this thing, a photon is emitted of energy E2 is H nu 2. And given various values of energy, we're supposed to find the energy difference between this guy and this guy, E1 minus E2. Okay, when you have energy pictures like this, so it really definitely serves like, let's call this E0, E final, like its initial. So you can say E initial, you can add E1, so got some place, right? That should be equal to this, all of these guys, whatever got lost in the new photon, plus E final. This is the ground state of positronium atom, plus kinetic energy of positronium. And from here I should be able to get E1 minus E2 will just be equal to EF plus kinetic energy of positronium minus EI. So this is the ground state energy of the hydrogen atom, this is ground positronium atom, and this kinetic energy is given. So that's all the problem is. So the main question is, do we know the values of this? This is the hydrogen atom, and it's basically hydrogen atom has electron and proton, and this is equal to minus 13.6 or something, but this actually is proportional to reduced mass of proton and mass mass of neutron, which is just happens to be mass of electron, mass of electron and mass of proton, not neutron. So reduced mass is like 1 over mu is mass of electron plus mass of proton, and this is like 2000 times heavier than that. So you can neglect that, and that becomes the case for hydrogen atom. For positronium, that's the main question. How do I get that? Well, so you can say it just, I can divide by this. I can divide minus 13.6 electron by, guess mu, this mu of electron proton system. Let's call it electron proton system, and multiply by mu of electron E minus system. It's just going to be scaled like that because everything else is same. It's same as that. These two atoms are same in terms of electrostatic energy, electrical energy formula. So the only thing is going to be mass of the. So you can say that this is mass of electron, but this is going to be what? So 1 over mu electron positron is equal to 1 over mass electron, another mass of electron. So those two are same mass. So 2 over mass electron. So this is equals to mass electron over 2. This stuff. So we get to cancel this, and so E final is minus 13.6 over 2 eV, which should be equal to -6.8 EV. This is minus 6.8 EV. Kinetic energy is given to be 5 EV minus 13.6 EV. So so this minus 1.8 plus 3.6 EV is 2.11 EV. So that will be the answer. So this turns out to be the main argument that you have to come up with, besides setting out just energy accounting. This is basically accounting of the energy in various processes. You start out with this, added this, took out this, and this is the positronium with moving. So this ended up with this, took out this. Okay, I think that's it. This is not a complicated problem, but if you don't know how to go from here to half as much, it can be a problem. And you have to know that this is actually proportional to the reduced mass. When you work out the formula for equation motion, it's a reduced mass of these two systems that play the role. Okay, that's kind of very specific knowledge. All right, see you in another video. Bye.